as a GeoAI engineer, I bring in the geo aspect. I usually have to develop AI models for various use cases. And for the model development, I have to train various models as well as evaluate their performance. And when evaluating the performance, we have certain metrics that we apply.
One. We are up. Hi guys, welcome to the GeoAI podcast. I'm your host Yariwo Kichio. And on this week's episode, we get into the world of drones and the use of GeoAI, which is a pretty new term. So I'm pretty excited about this episode and what goes into actually building models that can be used for some of the use cases we're going to talk about. But before we get into the episode, I'll have our guest introduce himself, and then we'll jump right into the world of drones and what a GeoAI engineer actually does. Hi, Chris.
Hi, Ariel. Good morning.
Morning, how are you? We're excited to have you on here. Thank you for agreeing to shoot this episode with us. For a start, Chris, there are a couple of new terms even in the intro. So maybe we can start with your background and then what you currently do.
I did my undergraduate studies at the University of Nairobi, which was geospatial engineering. And then after graduating back in 2019, now I worked for around 2 years. Later on, I applied for a GEM master's program, which is the MSc in Geoinformation Science and Earth Observation for Environmental Modeling and Management. It's an Erasmus program which is based in Europe, and you kind of have to study in 2 different countries. I managed to secure the scholarship as well and started my master's in Estonia for 1 year. Then the second year was in the Netherlands. In the Netherlands, the university here is the ITC, while in Estonia it was the University of Tartu. And I graduated last July, actually. That's July 2023. So currently I'm working as a GeoAI engineer at Spectral AG, still here in the Netherlands.
I'm very excited about some of the items you've mentioned. So it's a pretty interesting transition. I think for the scholarships bit, guys, we'll have a whole other segment for GEMS, not today. Can we briefly talk about the company maybe, and then now get into what GeoAI actually is, where you currently work, and your role as a GeoAI engineer? What does that mean?
Currently, I work for Spectral AG, which is more of a startup here in the Netherlands. Initially, Spectral AG started as a company which applies AI, mostly in the field of agriculture. But with time, actually, they now upgraded to more use cases of AI. So instead of being just limited to the precision agriculture, now currently we kind of apply more and more use cases. For example, in security, monitoring various infrastructure using AI as well. You asked about my role as a GeoAI engineer.
Yeah, because I noticed you've mentioned 2 things. So you've said the company is an AI company. So there's the AI company, and then there's now this other new term that we've brought in, which is GeoAI. So maybe we can start with that. The differences between these two, and then now narrow down into what that means for you in an AI company.
Okay, so when it comes to GeoAI, let's say by now, AI is a quite common term. So GeoAI now is in the integration of the spatial aspect into AI. So in simple terms, actually, just integrating the spatial aspect into the artificial intelligence field. Some of the tasks that I do as a GeoAI engineer, of course, I bring in the geo aspect. For example, when it comes to data acquisition, I specify the kind of formats that are required for our spatial integration. So be it that I want satellite data, aerial imagery from various platforms such as aeroplanes as well as, let's say, drones. So I get to specify the formats that are required. Then from there, as usual, being the geo people, we always have pre-processing bit. Let's say, of course, when you work with drone imagery, you will always kind of have to do things like mosaicing, auto rectification, and such. Then from there, now the maybe most common bit is the model development bit. I usually have to develop AI models for various use cases. And for the model development, I have to train various models as well as evaluate their performance. And when evaluating the performance, we have certain metrics that we apply. And after model development, next we have to do the model deployment. So when it comes to this model deployment, it's straight into production. And when I talk about straight into production, of course, now we have the drones as well as the robots. So these models are fed into these platforms for their various use cases. And apart from doing that, I also, as a GeoAI engineer, take part in the building of APIs through which various customers or clients can kind of get to access their models and train their own models as well, or even improve their models by further training. Yeah, then from there, bit is more of maintenance and updates. Of course, with time, we get to obtain more and more data, and you always want to have the best models that are carry out their tasks to the best of their ability. So we keep on training and updating the models with the newly acquired data sets.
And I like that you've walked us through the entire path of what it means to be a GeoAI engineer and where they sit within an AI company to bring out these spatial capabilities. So, Chris, maybe we'll go back a bit. Some of this workflows that a GeoAI engineer does to draw out the picture clearly. For me, who's a user, what are some of the lesser known workflows that a GeoAI engineer has revolutionized?
Okay, so in most cases, let's say for an AI engineer as well as a geo AI engineer, we generally try to do similar things most of the times, which is come up with train models for various tasks such as object detection, image classification, image segmentation as well. Then specifically for a geo AI engineer, let's say if you want to detect your objects and as well obtain the coordinates for those specific objects. That's where now we bring in the spatial aspect of the coordinates. As such, now when it comes to things like precision agriculture, so let's say we kind of fly our drones along somebody's farm, and of course, we may have a variety of bands in our cameras from the visual side of the spectrum as well as the near infrared. So we can obtain indices such as the NDVI or the NDWI directly. That's the water index. And from there, through the GeoAI, bringing in the spatial component, we can get to actually identify the specific portions on a parcel of land that we need, for example, to have specific inputs applied. So, of course, when it comes to precision agriculture, you have to work with more people, such as agronomists, so that at least for them, they can identify what could be the reason for these anomalies on a piece of land. And mostly when it comes to object detection, even at night, still, we kind of can identify objects at night using infrared. Most of the times for a GeoAI engineer, it's more about bringing in the spatial component. Where exactly is this particular object?
As users out there, when you're flying your drone and it's trying to identify like object detection or image detection and all that, the use case or where the GeoAI sits in there is the capability of that drone being able to capture those images and identify this is a farm maybe or this is something else comes in because a model was trained, a spatial model was trained, and a GeoAI went into training that spatial model. If I'm not wrong, Chris. So that's where you sit in that entire pipeline of ensuring that what the drone is capturing is actually in line with what maybe a client needs. Is that accurate?
Sure, yeah.
Why would I use a drone over the typical satellite imagery? What are the differences or what are the similarities in these two? So there's the different methods of acquiring data when it comes to remote sensing. There's drones, aeroplanes, and then there's the usual that we're used to, the Landsat and the Sentinels, the satellite imagery. What are the use cases? Why would I go for a drone over satellite imagery and vice versa?
Okay. So, of course, when it comes to satellite imagery, we've had things like Sentinel-2, we've had even Landsat. They have their advantages, of course, such as the large extents that they cover. And of course, for them to, of course, give us those large extents, the resolution is usually a bit on the low side. So when it comes to drones, specifically, most of the times they are quite flexible. You can fly at various heights. That means now you get to customize the kind of spatial resolution you want. Exactly. So that's one of the biggest advantage of using drones. And of course, temporal flexibility. It's not like the Sentinel or the Landsat images or the MODIs where you have to specifically wait till they are made available. So for your drone, you just take it based on the demand or when you want to use it and just fly. So that's the temporal flexibility. And apart from that, yeah, so we still have the aspect of real-time data acquisition and analysis. Maybe I'll just merge that point with task automation as well, because in this case, as opposed to satellites, maybe when you have your drone or you have your robot and you already have a trained machine learning model, or let's say deep learning model, when you fly it over a particular region, you can conduct various tasks such as monitoring. So simply you're just doing task automation. You don't have to kind of get the data, then do processing and other things for you to kind of obtain any meaningful information. So simply when you already have a trained model, you can stream everything from either the drone or the robot, so that if it's object detection, you can directly see like all the objects that are being detected on your stream. So kind of it makes the tasks real time. And of course, now when it comes to working with drones and robots, you don't have to kind of always be worried about the percentage of clouds. So those are the atmospheric disturbances most of the time. There are more advantages, of course, but then the satellite imagery themselves have their own advantages as well. But let's say for maybe based on the application of the user, you have to look at the trade-offs. Yeah, so that's it.
And then there's something you've mentioned which I'd want us to get into, and it's the machine learning models. When you're creating you've talked about machine learning and deep learning. I wanted us to get into that. Maybe from the basics again, what is a machine learning model? And then what goes into creating a machine learning model? I think that's now where you sit as a GeoAI engineer, and maybe you can give us some of the tips and tricks you use when you're building these models. But we'll start from the basics of what do you mean when you say a machine learning model, and then the building of it, what goes into you creating a model, for example, for a use case for a drone to identify maybe a farmland or object detect something.
Let me begin by first trying to general terms explain what is artificial intelligence, then machine learning, then deep learning. So when it comes to machine learning, I'll start with artificial intelligence, which is the entire field. So
Oh, the mother.
yeah, the mother of them all. So artificial intelligence, of course, is basically the study of training your computers or machines to mimic a human brain and its thinking capabilities. Or in other words, you're trying to kind of incorporate human intelligence into machines through various algorithms. I don't know if that's clear enough for
Yeah,
you.
that is,
Nice.
yeah.
So now we have the field of AI. Next, we have machine learning. So machine learning happens to be a subset of AI. And when it comes to machine learning now, you kind of give your systems, let's say computers or systems, you give them the data sets or everything they're required to just learn by themselves through experience without any kind of, let's say, human intervention or assistance. So in that case, you just want to give your machines or computers all kinds of data, then they themselves can kind of come up with various patterns in your data. And then finally, we have deep learning, which is a subset of machine learning. Yeah, so when it comes to deep learning itself now, it's a subset of machine learning now, which makes use of neural networks. So by saying neural networks, similar to the human brain, which has neurons, now it has these layers which are referred to as which kind of bring in the aspect of the deep thing, of the deep part. So you have a variety of layers, very many of them, ending up with a deep model. That's where the term deep comes on. And of course, as we said before, you just want to kind of, the main aim of AI itself is try to mimic the human brain. And the focus of AI is usually to learn, to reason, and self correction. So, and I think maybe a common example, you've seen ChatGPT. It tries to reason, gives you some very wrong answers, and then it tries to kind of do self correction as well.
Chris, let me ask before you go on. So within all these terms, the AI, the machine learning, which being a subset of the AI and deep learning going even deeper, from a practical scenario, what differentiates them? Is it the data you're using? Is it the intensity with which you're training? Is it the diversity of the data you're using to train the model? Like what differentiates this in terms of the practicality of the work you're doing?
It's a nice question, actually. But then the point here is deep learning is already a subset of machine learning, and machine learning itself is a subset of AI. What I specifically do is deep learning, which is more of coming up with working with neural networks. Those are the models. Yeah, those are the models. So, and of course, when it comes to deep learning itself now, you have various tasks that you can achieve, and some of these tasks are object detection, image classification, image segmentation as well, or even instance segmentation. Yeah, so when it comes to object detection, you want to kind of, the task here is kind of identify that this is a particular object and then localize it, Okay, you localize it by kind of drawing a bounding box around the object. Then for image classification, being maybe from the geo background, it's very common for us, especially in remote sensing. You want to classify each and every pixel of an image into a particular class. And then usually it can be confusing for people when it comes to both image classification and image segmentation. But then segmentation is a process whereby pixels of an image are classified into various classes, and then some kind of polygons are then drawn along each and every class. So that's the major maybe difference between the classification and segmentation. So after the classification, we have some kind of lines being literally drawn along the boundaries of the classes so that you can segment out various objects.
I think I also confuse image classification and image segmentation. So classification is the usual one that we do, water, vegetation, all that. So image segmentation is it me going further?
So it goes further now. For example, in segmentation, we have both semantic segmentation and instance segmentation. So after the classification now, we kind of have lines or polygons which are drawn on the image to single out now the various cases of the classes that we have. So semantic segmentation, for example, if you have people on an image, it will kind of make masks based on the polygons being drawn. It will make masks of the people. But then instance segmentation now will kind of separate one person from the other. Like this will be person one, this will be person two. That's generally segmentation.
A whole remote sensing class. Thanks, Chris. This was very useful. Your daily tools of trade. What do you use to build these models? And do you always start from scratch, or are there resources you can use online and just maybe now make the model or customize your model? Can you walk us through now the model building itself for you as a GeoAI engineer? One use case, for example, that you've had, me, for example, maybe you wanted a drone to identify farmlands. How do you go about it? How do you track back and now get into creating something that feeds into that drone to identify what you need for a client would help us understand even better some of these models and what goes into creating them.
When it comes to these models, maybe training or building the models, the first thing is you have to be clear about what you really want to achieve. Is it object detection? Is it image classification? Is it segmentation? Because with each and every task, there are a lot of models out there which are good for particular use cases, and they have various advantages. Let's say accurate in terms of accuracy. Some may be not as accurate, but then they are really fast. So you always have to kind of figure out or consider the trade-offs. So, for example, when it comes to object detection, we have a variety of models out there, and the most common ones or the popular ones when it comes to object detection are the convolutional neural networks. For example, faster RCNN specifically. And then we still have the single shot detectors, which are SSDs. And we even have the YOLO as well, which is the you only look once models. So those are the mostly the ones usually see being used in object detection. But there are way more of these models out there. You just have to kind of do research based on what you really want and then kind of make a decision. When it comes to applications such as classification, we also have different models such as AlexNet, VGGNet, ResNet, ImageNet. Yeah, so it's that open.
For your scenario, when you're using these models and when you're building these models, what's the workflow? You'd identify them and then use them to train your own model. Is that how you'd approach it for you as a GeoAI engineer? Or how do you sync what's online with you creating a local solution for your client?
Yeah, good question. So you have the option of either building a model from scratch, which could be a lot of work, but then still, currently we have plenty of models which are existent. So leverage the advantage of using transfer learning, which transfer learning is now you have a model which is already trained. So instead of building yours from scratch, you can just train the already trained model now to kind of detect your specific objects that you want to. Yeah, so now instead of always coming up with a model from scratch, you just have to go around, look at what are the models which are available. Now you can retrain these pre-trained models.
I didn't even know that's called transfer learning. Thank you. You're going to sound smart after this conversation. When you're building, are there tips and tricks you use? How do you determine accuracy in your scenario as a GeoAI engineer, creating these models that work for your scenario?
So, of course, when it comes to after you train your model, you want to evaluate its performance. So, the first thing is You can do that by looking at various metrics. As you said, metrics such as accuracy, the precision. Of course, we have other metrics such as the recall, which is, let's say, out of all the actual positive instances, how many were predicted as positive. That's the recall. Then we have the old confusion matrix as well. If maybe you have a remote sensing background, then we have, let's say, the mean average precision, the MAP, which is used to evaluate the ranking tasks by, let's say, measuring the average of precision scores after each relevant item that you want has been retrieved. So we have a variety of metrics, and of course, you can always look at these metrics as the first check to see like how well your model is doing. And apart from that, of course, after training a model, you can just load it into a drone and do it real time, like test it real time.
Okay, so after you've built it, you now test it with a drone to see how it reacts to the model, if it's able to identify or not.
Exactly. Yeah, exactly. So you can just load it into a drone or even a robot and then just use it to try and apply the kind of use case that you train the model for. So I think that's even much better as compared to just looking at metrics. So those two actually kind of give you confidence that your model is at least doing what it's supposed to do. But then initially asked a question about the accuracy of your model or some tips and tricks. So I would say the models that somebody trains are as good as the data which was used in the training process. In the first place, you should have high quality data with high quality labels as well. And from there now, the more the good quality data, the better the model, because you want to train your model based on all kinds of use cases so that whenever now it comes during like the real-time predictions or such things, it has seen these different use cases before, such as images which have different backgrounds as well as maybe from different locations. And the advantage is once you at least have a good model, and let's say you want to create labels the next time, you remember the bit about the digitization bit, like that most people in geospatial hate. Yeah, yeah. So at least with a good model, you can automate these processes instead of having to label each and every image by yourself manually. You can always automate these tasks based on trained models, so it makes life easier.
You've mentioned a couple of things there. So after you're done training, then it comes into you actually testing out that model within a drone. Are you in a position to talk about what the team dynamics look like and all the different people that bring this to life, because you're not doing the heavy lifting by yourself?
Yeah, it's true. So we usually work with, let's say, mechanical engineers, of course, who work with the drones as well as the robots. Apart from mechanical engineers, we have software developers who kind of will come up with the APIs as well as the applications that we use to load our models into the various platforms. Then we have other machine learning engineers as well, so with whom we can build the models. Apart from that, now we have, let's say, the sales team, because we have to know like what the customers want exactly. So because you cannot just build these models in a vacuum, you must know like what are the use cases and what exactly do the customers want. Yeah, so these are some of the people we work with.
What would you say are your daily tools of trade?
I usually use plenty of Python. And apart from Python, now I have to kind of work with the platforms themselves when it comes to testing the models. So I work with various technologies related to those specific platforms.
Would you ever use traditional JS softwares for this?
Ah, I forgot. I'm always thankful to QGIS, of course. Because whenever you're working with spatial data, sometimes you just need some quick fixes and you need some quick analytics. So you can just always throw some image into QGIS as well as maybe some shapefiles as well and do some kind of quick analytics. So QG is always comes in handy. Yeah.
So, Chris, I'd want to get your thoughts on what would you say for guys in Campo or guys who are trying to figure out different career paths, and this is one of them, and that's why I thought this conversation was very central. What would you say are the must-have skills at the moment that you think guys should master, especially the dynamic we're talking about, people in campus and people who are just getting into the job market? What would you say are the skills that we should master as a community?
Ah, okay. So when it comes to the skills that maybe would help somebody in such a field, so first you have to kind of know your stuff when it comes to the geo side of things, because that's the original thing first. So you have to kind of understand what usually happens, what do I need to do for various scenarios if I have, let's say, drone images, you just generally have to know the geospatial workflows. So after that, of course, after you know the workflows, you have to be familiar with the tools that you can use. For example, you can use the GIS software such as ArcGIS or even QGIS, as well as various other languages such as mostly Python. Python, of course, in geospatial nowadays is very important. Python is really important, so you can use either this. Okay, you can actually have both of them, Python and the GIS software. So apart from that, you of course must learn how to collaborate with other developers because you cannot work in a vacuum, as I said before. So Git is kind of very important. Yeah, GitHub. Yeah, so because you have to collaborate with other developers as well. And then apart from that, some extra skills will not harm you at all if you have some basic web development skills, because sometimes you need to kind of come up with APIs through which various users can consume your output. So some web development skills, because you need to understand and work well with other people as well in the field, such as the developers mostly. Yeah, so you kind of need to understand what's happening generally. So I think that's it. And of course, you're not limited to just that. You can keep on exploring.
Are there any resources you think would be useful for the community to look up for, especially again the young audience that we have, that they can look up if they want to know more and maybe start learning or start practicing with some of these data sets?
Yeah, so currently, when it comes to the materials that are available out here, we have the advantage of YouTube currently. YouTube itself has plenty of material and how to do such things. So I think that's the first direct point I would point somebody to. Because if for a particular use case, maybe they first need to understand what they really want, then from there, you can find plenty of material on YouTube. So from there, around the net, we have plenty of resources when it comes to artificial intelligence with Python. For example, we have this course on harvard.edu. They provide an introduction to artificial intelligence with Python. Yeah, so maybe I can share some of these links. And I think it's currently a free course. Yeah, so yeah, on Harvard, there's the CS50s Introduction to Artificial Intelligence with Python, 7 weeks long, but then you can always compress that because it's self-paced already.
Oh, that's interesting. Guys, I'll share the introduction to AI with Python, the one for Harvard. I'll share that link in the podcast description for this particular episode for you guys to look up. Thanks, Chris. Is there any other website you can direct us to apart from the YouTube and this one?
From there, maybe the direct websites for the various models, because for each and every model, most of them they have their GitHub repos, and their GitHub repos themselves kind of give instructions of how to use them based on the use case that you want to apply. Whenever you know the model you want to use, most of the times they have a GitHub repo with instructions or guidance on how to really use the models.
Thank you. I'll share this as well, guys. Thank you so much, Chris. This has been very insightful. Thank you so much, guys, for listening in. We'd love to hear from you. Let us know what you think of this episode, this conversation, and what else we can do to make the conversation even better. Please also suggest to us who else we can host on here. We're more than open to reach out to more people, have more diverse conversations as we all build our technical brilliance. Until next time, bye. Do you have any parting thoughts?
Mzinga iko wapi?